All right, CNT120, we're working on Chapter 3, and we're in the section on domain names, fully qualified domain names. So first term they're going to introduce us to is the Uniform Resource Locator. This is our browser bar that we plug our names into. This was developed as a way for us to type a name in and get to a resource like the IP address of a web server, because it's easier for us humans to remember name versus a long IP address that we would need to plug into. This was developed as a part of Tim Berners-Lee project of developing web server, World Wide Web, etc. This was all developed as a way to find a resource by name. And if I look at this whole thing here, each piece here, first part protocol, next part here www, domain name, example.com, or a host name www for a web server, domain example.com, and then this the actual file name to load the website, if you will. This was all created as a set, if you will, for the first web server that we had. Tim Berners-Lee, that would be a good informative speech topic for people. So as we look at this again, we looked at this before, as we look at this again, fully qualified domain name will be something like www.hack.edu or www.formula1.com. The last part, hack.edu, is the domain, or formula1.com is domain, and that first part, www, is the actual host. In this case, www is the web server for the hack.edu domain, as opposed to the email server at that site. And again, www would be the web server for formula1.com versus the email server at the formula1.com domain. The book uses this picture here and shows just that same idea, breaking it out for you. Fully qualified domain name, host name is the first piece, the domain name would be the last piece, hack.edu. The last part of our fully qualified domain name is your top level domain. Things like your .edus, your .govs, your .govs, .orgs, .coms, etc. Those domain names are registered in the authority that works on behalf of the Internet Naming Authority that works on behalf of ICANN. These domain names need to be registered with ICANN. I'll get it yet, my goodness. Now, ICANN restricts what types of hosts can be associated with some of these top-level domain names, but here are a whole bunch of top-level domain names that we might recognize. And actually, there are top-level domain authorities, the authoritative server for .com, the authoritative server for .edu, and you can actually look these up at the IANA website. They have a listing of those, who's the authoritative server for .edu and so forth. Now, let's just apply a concept real quick to start understanding DNS. If you want to register a domain name, now I bought a domain name for my wife's, for her business, for her web server. So when you buy a domain name, you go to a registrar, a place like GoDaddy.com, and you go in and search to see if the domain name you want is available. You know, networkingisawesome.com. You search to see if it's available. If it's not, you need to change your name. If it is available, you could buy it, and it might only cost you 20 bucks a year kind of thing, 25 bucks a year to have that domain name. Well, if you say I'm going to buy it, part of that process is you plug in your name, you plug in your address, you plug in your email, you plug in your phone number, those kind of things. But then you also plug in that, hey, this networkingisawesome.com, we're going to point to this IP address. And that IP address would be the web server that I'm going to host the website on. That way people could actually find it. Well, when I buy this domain name with this registrar, they actually start registering it and passing it through the domain tree, if you will, DNS tree, to the authoritative servers to say, hey, Networking is Awesome maps this IP, and within usually about 24 hours, people can search for that domain name and get to that web server. Those two, that process of buying the domain name links those two things up. So, since that is done, we can now search for who owns a domain name, and we can use tools like domaintools.com or command prompt NS lookup to see who owns a particular domain name, because that that had to be registered when you bought it, so I can reverse that and see who owns a particular domain name. That's that lookup process. All right, now before we dig into anything more DNS, let's do a quick Wireshark of DNS protocol to see the process occur. All right, let me pause while I just adjust the screen, and then I will come back and show you that. All right, I have Wireshark up here, and what I'm going to do is I'm going to, on my wireless NIC here, I'm going to start a Wireshark capture of traffic. And while I'm doing that, I'm going to communicate to a web server to try to learn its information, and we're going to try to capture that DNS traffic. So let me start my capture going here on my wireless card. There it goes. I'm going to put a filter up here that I only want to see the DNS traffic. While that's running, because it's still running right now, I'm going to open my command prompt, and I'm going to ping something like I had pinged Google before. So let me ping something different now. We're going to ping something like www.formula1.com, because I'm a Formula 1 nerd. I'm going to try to ping that, and I hopefully will have DNS traffic in the background resolving that name into a number. And I did actually get a successful reply, so that should have worked in the background. All right, and I do have some data. I'm going to stop my capture because I don't want to capture more packets. And we're going to take a look at, here's the first DNS request. And if I, excuse me, look at the arrows over here, this request goes to this reply. So here's the query request, and I should get a response here. So let's look at the query. I'm going to open that up, and if I look at the DNS header down here, here's the query, and it says, hey, somebody was asking for Formula1.com, and we'll see this is a type A. That's an IP version 4 request. I'm going to look at the response now, the query response, and I should have gotten a number back or a response back. And if I look down through here, I do actually have a response in the form of this IP address here. Like, hey, try this IP address. And it even shows it down here. Try this IP address to get to that website. And that's an IP version 4. Well, if I look up here at the query again, the quad A, that's an IP version 6 request. Hey, what's the address for Formula1.com? If I look at this query response, quad A, that should be my IP version 6 address response. So as I look down through again, it's like, hey, what's the address for Formula1.com? We're going to come down through here. Here's the response down here. Here's the IP address, 2600, 9000, blah, blah, blah. And I think if I look at my ping over here, yeah, 2600, 9000, blah, blah, blah. That's the response I got back, and I was actually able to ping that web server. And the only reason I could is it resolved that name into an IP. So when I pinged here and I pinged the name Formula1.com, it had to DNS and get the IP, and then I could start pinging that IP. That's your DNS process. We're taking a name into an IP so I can find that entity. All right, we'll go back to the podcast here in a second. I'm going to pause while I change screens again. And we're back. So hopefully seeing that DNS process, some pieces start to fit together a little bit. That's the kind of thing that helped me when I was learning this. So the name resolution process is just that. If I know the name, it'll help me get the IP address, if you will. And DNS is the thing that's doing that. The DNS server is the thing that's doing that, developed back in the 80s. Now, initially, this is a fun little side tip. Initially, there was a person that was actually doing the DNS, if you will. Jake Feindler was her name. And in the 70s, she ran the NIC, basically Network Information Center, and wrote the resource manual for ARPANET, and basically was the host database for ARPANET until DNS was developed like almost 10 years later. So here's actually a picture of her sitting at the desk with, she had manuals and pages that people would call and say, hey, what's the IP address for the server at University of California, Berkeley? And she would look it up and say, hey, here, this is the address you're looking for. That's how you'll make connection. She was the original DNS, and then actually the DNS servers got developed and was able to respond much quicker over time. But she was one of our early internet heroes, Jake Feindler. So DNS, domain names and DNS, we're looking at application layer protocol. It's designed to associate computer names with IPs. Application layer client server system, and is made up of a bunch of elements. You have the namespace, the entire collection of computer names and their associated IP addresses. The name servers, these are the databases that are holding this information. If you go back in time, we had phone books to look up people's names and phone numbers. This is essentially that kind of idea for servers. The name and its associated IP address. And again, that information gets in there from when you buy a domain name. You actually plug all that information in. The server holds on to it and says, okay, now I know this name goes to this IP. Gotcha. And it can hand that out. The resolver is the DNS client that requests information from the server. In my case, when I pinged earlier, I was asking for that, hey, does anybody have that IP address for that name I plugged in? There's different types of servers. The main authoritative server for for an organization. Secondary, it's a backup that's there as just as the name applies, a backup. And then you can have a caching DNS server. Access the public DNS data and caches it, and can actually help with speeding up that process. And then a forwarding DNS server, which is optional, receives queries from clients but does not work to resolve them, just kind of maintains a cache from previous queries and uses that information. DNS servers are organized in a hierarchical structure. You have your root servers that we mentioned earlier. Then we have top-level domain servers, com, org, edu, and so forth, and then the authoritative servers for specific companies. There are like 13 clusters of root servers that hold the information. This is from IANA, showing the root servers scattered around the globe, and actually here scattered around various parts of the globe. The top-level domain servers hold information about the authoritative servers, and those are your authoritative name servers for particular domain names and how to find them. They're at this part of the structure. And you can actually look up who is the authoritative name server for a particular top-level domain. I can actually go to IANA and go to the root zone database, and in there scroll through and look for things like .com and say who's the authoritative .com server. In this case, it's VeriSign. Some of you might recognize that from doing online purchasing. You'll see VeriSign show up in the corner of the screen. .edu, EduCause. If I look at .net, VeriSign again. If I look at .org, Public Interest Registry, I'll get it out yet. So here's some top-level domain authorities. Authoritative servers hold the database and names and IP addresses for computers in their domain. Again, it would be here, hacks.edu server, DNS server would have all of that. And here, example, I pulled up Hack. And this actually I pulled up just a couple days ago, showing when all this information was updated. Your DNS process, it actually shows me asking local DNS server, and then the process it goes through to get the domain name if it doesn't already have that in place. So it's actually going to hit a number of different servers to resolve that, and then hopefully maintain that so it does not need to go through that process again. Two types of DNS requests. You have recursive and iterative. A query demands a resolution or it can't be found. And the iterative is a query where the local server issues queries to other servers. Hopefully they can find the information for you and get back to you. In your DNS database, there's a number of different records. We actually saw the A record and the quad A record as we were doing our DNS example earlier. Here, conical name, the name for that host. Pointer record used for reverse lookups going the other direction. Name server record, here's your mail exchange record, and so forth. So a number of different records in your DNS database. And then this is some of the stuff that the book had for you, showing examples of those pieces. Two main DNS servers out there, Bind and Microsoft DNS Server. The main one that's used is your Bind. That's your Berkeley Internet domain, name domain. I'll get it yet. It's an open source that gets used and is very commonly used for name DNS servers. All right, as we come back in the last podcast, we'll talk troubleshooting.